So my talk is on blockchains. So first question is, how many of you have heard blockchains before? About 5 people. And that is the whole purpose of giving this talk, because this is something that is happening just now, started, and we all need to know about it. Okay? And so you don't need to copy any slides. All the slides are there. You can download them if you have the internet now or later. So let's move on to the next slide. There are 4 parts. A new trend has started, centralized to decentralized. It's really interesting. Every 4 or 5 years, the time, as we say in Indian culture, time is a chakra. So we come back to the same belief after some time. So now we discussed few years ago, 5 years ago, we discussed to have centralized, right? Before that we had distributed everything. Then with SDN, we went to centralized. Now, from now on, we will talk about decentralized. Okay? And so let's see why that is happening. How does blockchain do it? What are the techniques? Oh, by the way, blockchain is related to Bitcoin. So Bitcoin probably everybody has heard, but they don't know how it works. And so we talk about as to how it works, and then how that relate to blockchains. So one of the contracts that we make in our life, most important contracts, some of you have made it, some of you are looking forward to it, is marriage. Right? And there are 2 ways to do it. One is you go to an office, maybe the collector here in India or registrar, marriage registrar's office, and you get married and you get a certificate and that's it. The other way is you bring the whole town with you, we call it a barat, and you don't get a certificate, but you are married. Right? Now think about the good and the bad points of both systems. What is good about this system and what is good about this system? Now, it turns out that this is what we call a centralized system. There is a central registry where all the married people's name is there, right? Who is married to whom? But there is a problem with that system, and this is decentralized because there is no registry at all. Right? This is decentralized. So the disadvantage of the centralized system is that's a single point of failure. If somebody burned the collector's office, you will not be any longer know who you are married to. Right? Or somebody could change the entry by giving a bribe to the peon there and say, please change the name. And so there is a single point of failure. And it is very easy to hack the central things. So now we are coming to a point where the hacking is going on so much, so we prefer this old system where there is no central point of failure and nothing can be hacked. Now, if you want to change the wedding record, if you are married in a barat, you have to go to 51% of the town and say that, okay, please lie. Of course, then you can get married to somebody else, right? But you need 51%. If 51% are bad, then of course you don't have any hope for a good world, right? Good world. So as long as less than 50% are bad actors, the world is going to survive, right? And so that is what we are going to talk about. We talk about that, blockchains. Now I'm going to just give you one slide introduction right now, and then the whole presentation is about blockchains. So what the blockchain does is that it allows any 2 complete strangers who don't know anything about each other, to make a transaction, make a contract, make an agreement, and without a third party. Okay? And in the first generation, the blockchains were used by Bitcoin. All right? And people didn't realize that this is very good until the Bitcoin became very successful and people started looking inside the technology to figure out how does it do it? How does it do it? And they figured out that the blockchain is the key. So the second generation, they extended the money exchange. Bitcoin is basically you give them one coin and then you get one piece of drug or something, whatever you need. And so that is what Bitcoin is for, right? For most of the time, actually. I will show you different activities, but Bitcoins is money exchange, right? Then they extended it to contracts, agreements, and property, or any kind of agreement you want to make. And that is what is happening now. That is what has started happening about a year from today, basically last year. And so suddenly, everybody who deals with property, agreements, anything you do, I mean, we'll see the list is very big, is interested in blockchains. And so you should be interested in blockchain, and that's why I'm talking about it here. That includes manufacturing, education, computer networking, and everything. All right? So how is it done? Basically, it is called a blockchain because there is a chain, and we know in computer science what is a chain. There are pointers going, but in this case, it is not going pointers both way. It is singly linked chain, so the pointers only goes backward of blocks of verified signed transactions. So this one says that, look, I mean, it points to the previous transaction, and this is the transaction, and it is replicated globally on millions of nodes, and that's the strength. That transaction doesn't exist in one place. It exists on every register possible in the world, on every computer, or at least the computers that are participating in this whole business of blockchains. So there are so many copies that you cannot just change one copy and assume that now you got the money, or you got the property, or you can change the agreement, right? It's the number of copies that are made is what is the strength. You will have to change millions of nodes to attack or change anything. So who is interested in it? As I said, banks, ISPs, venture capitalists, and because venture capitalists are interested, we people who want to have a startup, or researchers, or students, we're all interested. Okay? And it has been proven to be cryptographically secure. So this is very strong in security business. So you need some security experience, security knowledge to understand this thing, and hopefully we will be able to get through it. And it is hacker proof. Remember who deals in the bitcoins? People who sell drugs. They don't accept dollars. They don't accept rupees. They only accept bitcoins. People who hack your computer and want a ransom, you know what they want from you in payment? Bitcoin. They don't want rupees and dollars. So if you are dealing with such people, how can you make it hacker proof? And that is what the beauty of this thing is. That this is so secure that all these bad guys cannot hack it. No single point of failure, and it achieves a decentralized consensus. So the word consensus is that the whole world agreed that this agreement was made. That is a consensus. And it is decentralized, means there is no single point of failure. And so basically this consensus, this agreement, this agreement is made by just the whole world. So examples of centralized systems. Centralized system is a bank. If I want to give you $1, I will probably write a check on my bank. You will take it to your bank, and without that you cannot get the money. So you have to go to the bank. That is centralized. Currency. If I want to give you $1, the only dollar can be printed by the US government. It cannot be printed by Saudi government. It cannot be printed by Indian government. So there is a central point where the control is, the US government. Right? Same thing for rupees, the Indian government. Stocks. If I want to buy a stock from you, you have one stock and I want to buy that stock, I cannot just buy it from you. I have to go to the stock exchange. You have to sell and I have to buy. Now all of these are central registries. At each of these places, somebody keeps track of, not in the case of currencies, but in the case of stocks and banks, somebody keeps a register which can easily be hacked and often hacked. Credit cards are very important. Another example, I want to buy something, I give you a credit card, you write down the number, and then you keep that because you want to be safe, and then that is the first thing that is hacked, because you have a register of all the credit cards. So in all cases, there is a third party to be trusted. This central party maintains a large database of information, and whenever there is a large database of anything, people want to hack it. And then they affect millions. So you have heard, how many companies have been hacked, how many countries have been hacked, and, big companies like Sony and so on and so forth. The central point party is a single point of failure, and if the central party becomes bad, then you can't, you can't do anything. If suppose some bank employee or bank itself goes bad, you all lose. So that's why we don't like centralized system. So the trend is to make everything decentralized. You can send the money, now with this decentralized system, you can send the money to Russia or to China without the government knowing it. Okay? Because there is no central point. The currency is global. This Bitcoin is global. It doesn't belong to a country. You can just get the Bitcoin and you can use it here, and you can use it there, you can use it in USA. So this is the strength of it. And you can make a wedding contract, you can make a property contract, and so on and so forth. And the decentralized systems are more reliable, as we said, because they are fault tolerant, they are more secure, there is no single point, so they are very fast. So that's another thing. When you have a single point which controls everything, they charge you a lot of money. So the banks charge you money to, basically do the credit card transactions, and so on and so forth. And if there was no central point, then it would be much more cheaper, maybe even free in some cases, to make those contracts. And so there is no monopoly, right? So libertarians, the people who do not believe in the government, they decided to make a system which is totally decentralized with no central authority, and they found that the blockchains is the way to do it. Now this is called the fifth disruptive computing paradigm. The first was mainframe, which created IBM. Second was personal computer, which created Microsoft. Third was internet, which created anything from Netscape to Google. And the fourth was mobile and social, which created Apple and Facebook. And the fifth is coming. That is blockchains, and that's where people are believing that this is going to change the whole thing as to how we exchange money, how we do microfinancing, how do we contracts, and machine economy, and so on and so forth, how the IoT machines can pay each other. Now microfinancing is another interesting example. If I want to give you 10 paisa, actually, the value is so low that probably you don't want it anyway, but I'm just saying that it is very difficult to do that because there is so many fees involved, and some small amounts cannot be loaned or this. But in this currency, you can do anything you want. Now look at the blockchains interest from Google trend. If you go to Google and ask, how many people are searching for blockchains, you will find that not many people were searching in 2011. Really, the interest started somewhere here last year, and suddenly now it's going up, exponential growth. So you are not alone. If there are only 5 people who know blockchains, rest of you are not alone. I am in the same group that I did not know.
So why is Ghana so interested in blockchains?
Huh? Oh yeah, now that's, notice another interesting thing, that where are these people looking for? Most people are in Ghana. And the reason is they don't trust their government. Right? And they need that whole thing where they can do anything without the government. And so you see South Africa, Singapore and all that. So basically, I found that interesting, that's why I put it here, that Ghana is where most of the action is for this. But anyway. And suddenly everybody notices this, and if you have attended many of my talks, you know that I always present a Gartner's hype cycle, and this is right here. Basically what this is that every year Gartner publishes a report that what is hot this year. And this is the report that the companies use to buy companies. This is the report that the venture capitalists use to invest into startups, and this is the report that we researchers use to find out what to work on next year. And here is the report for this year. So these technologies which are listed on the left, these are what they call, they are very new technologies and they are increasing in hype. Basically, the ones that are at the bottom are really that they require a lot of work, and that is generally done by the students because there is no money to be made and we need a cheap labor, right? As the technology gets developed, they move up the chain, and at this point, they become companies, startups, and the VCs start investing. So this is where the VC investment is. As the hype increases and they go to the top of the hype, then the big companies start buying. So this is where the big companies are buying these technologies. And as the technology becomes mainstream, then it comes here. At this point, everybody gets out because the technology goes to China. Why China? Because then the only differentiating factor is manufacturing cost. And you cannot do that in India or you cannot do that in USA. So then everything and that technology comes from China. Right? So we researchers have to keep on the left side, and this is where the VCs invest, and you see the blockchain is almost there. On the top of the hype, by the way, is machine learning, and this conference is about machine learning. But next year, that will move to the right, and blockchain will come to the top, and this conference will be about blockchains. Who knows? Right? But this is the thing. Interesting thing is that this was not there in 2005 and prior hype cycles. So Gartner publishes the report every year, but they didn't notice the word blockchain in 2015 and 2014 and 2013 and 2011. So suddenly in 2016, they put it on the top. So basically this is true. It is just coming up very fast. The hype is building. So this year, VCs are going to invest $1 billion on blockchains. In 2015, they invested $500 million, and so on and so forth. You can keep going back. And you can see how it is going up, and there are lots of startups. I wouldn't go through that because there are thousands of them. So this is basically where people are just looking for some idea as to what can I do in this space so I get some money. So how did blockchain start? It started from the Bitcoin, right? And blockchain is the technology that made Bitcoin secure. It was invented, the blockchain was invented by this one person who invented Bitcoin. And after the Bitcoin became successful, people started looking into the technology and suddenly found blockchain. So what is Bitcoin? Bitcoin is the first successful virtual currency. A lot of people wanted to have virtual currencies before, and there were attempts where you could just send somebody money without having a real dollar in your hand or rupees in your hand. But it has survived 5 years and has become legal in several jurisdictions. It is legal in the United States. Okay? It is decentralized. No one company, no one country, no one person controls it. It is decentralized transaction verification, decentralized ledger, decentralized mint. What is a mint? Mint is where you print the notes, print rupees and dollars. It's decentralized. Decentralized peer-to-peer network. Everything is done on a P2P and with all the good and bad points of P2P. Has been designed to control over-minting. You cannot overprint it like some countries do. Ghana is one of them maybe, where they just print so much money that the currency has no value. Right? You cannot do that with Bitcoin. It is designed to control double spending, so you cannot have Bitcoin and give it to 2 people at the same time. It is designed to control counterfeiting. You cannot just make a coin by yourself. And one Bitcoin, yesterday's rate was $620 US. Rate changes every day, just like any other currency. And the total right now are 15,000 something BTC, that is $10 billion can be exchanged today. And generally people don't talk about one BTC, $600 is a lot of money. So minimum you can do is 10 raised to minus 8 BTC, which is like 0.0006 cents. Okay, and that is called Satoshi. 1 Satoshi is 10 raised to minus 8 Bitcoin. Why Satoshi? Because Satoshi is the name of the person who invented Bitcoin. Anyway, so now this is a currency which was illegal or considered illegal if you were if you are seen searching about Bitcoin. Maybe the CIA will come or somebody will come and say, hey, what are you doing, man? Right? But now it is legal. There are 30,000 vendors that accept Bitcoin, and believe it or not, next time you go to Dell, Newegg, Tiger Direct, Sears, Square, Subway, or any other place, they accept Bitcoins. Okay? So now you're in good company. So who invented it? There is a guy who nobody has ever seen, so it could be a pseudo person, I mean not a real person, maybe a group, maybe somebody, we don't know. But he wrote a paper, white paper in 2008, his name was Satoshi Nakamoto, and he wrote the whole thing, how to do this whole Bitcoin thing, how to directly transfer the money without involving a third party. So he wrote a white paper. Since he did not write a paper, but wrote a white paper, clearly he was not an academic. Because if I would invent Bitcoin, first thing I would do is submit to a journal. Right? So this guy is not an academic. Second thing, he is not an academic is because he also wrote the whole software. So he published the complete reference code to transact, store and mint Bitcoins and make the software open source. So you can read it, you can change it, whatever you want to do. So this Bitcoin software is open source. And he did this. This guy, one guy did it. So clearly this guy is very practical. He supported the software and answered all questions for 3 years, from 2008 to 2011. You ask any question and he will answer it on the website. And then he disappeared and has never been seen. Okay, why he disappeared? Maybe he was too rich. Maybe he was too fearful. Why rich? Because he knows how to mint. And and we'll see. So the people who mint the coin, they get money. And second thing is fearful because many governments are catching people who were dealing with Bitcoins, even the United States and other countries. In fact, China has made it illegal. If anybody is found with a Bitcoin, they are put in the jail right away, even today. Okay? So he probably was very fearful that he will be caught, and so he just said, okay, bye-bye, done. So anyway, it's P2P network. Nodes come up and leave at random, so the network is not trusted at all. I could become a part of the network, you could become a part of the network, and transactions go through everybody. Anybody can change the transactions, but they will not go past the next hop, because everybody, before they forward the transaction, they check it out that this is valid or not. Packets could be delayed, lost, duplicated. Some nodes could be bad. As long as the majority of the CPU power is not with the attackers, the system works. And this is the key, the CPU power. It's not the number of people, it's how much CPU I have. If I have this big CPU, I have more power. And so that's the key, is that in this thing, as we'll see in a minute, they require you to have a lot of compute power before you can basically, if you have little power, then you don't have much power, right? So as long as the majority of the CPU power is with the attackers, the system works. And so this is called proof of work. You have to prove that you have this much compute power. So there are 3 things that go into Bitcoin: game theory, cryptography, and peer-to-peer. P2P we all know. P2P is basically that, if you want to send something, you just send it to all your neighbors, they send it to all their neighbors, or whoever is part of the network, and if you want to get something, you just ask from the neighbors. That is P2P. So the cryptography and the game theory. Now cryptography is also very well established. With cryptography today, we can sign documents, and we all do, and they are valid in the code. If somebody changes a word, then the signature is no longer valid, right? So that kind of thing is used in this. And we all do hashing. For example, in hashing, you can take a big information and transform into a small set of bits. But if you change anything in the main message, the hash will not match. So that is one. So we know all this in the cryptography. And game theory part is that everybody has to benefit, otherwise they will not work. right? So the people who mint, the people who verify, the people who do all this, and they all benefit somehow in this whole game. So if you want to start in Bitcoin, it's very easy. If you have your smartphone, iPhone or the Android phone, just go to the Google store or iPhone store and just say Bitcoin. And you will find hundreds of apps. I was really surprised. I never looked for those, but once I looked for them, there are hundreds of them. And I just listed 10 here: Coinbase, blockchain, Bitcoin, and so on and so forth. You just get it on your phone and get it started. You can buy your first Bitcoin. You don't have to buy one Bitcoin. You can buy 0.001 Bitcoin or whatever you want to buy. And you put your money in and you are in business. Okay. So what this wallet program, this is called wallet programs. These are all wallet programs. These are wallets that you keep in which your Bitcoin basically, I mean, there's no Bitcoin there, but there is an account somewhere. Your program wallet keeps track of how many Bitcoins you own and what names have you used for owning them. That's another interesting thing, is that you don't use your real name. You just use a number. And you generate that random number randomly. Okay? So with this random number, I own 1 coin. With that random number, I use 2 coins and so on and so forth, and I can pay 3 coins to somebody. So nobody can really know what number belongs to them, whom. But every number is associated with a private key and public key. So those of you who know cryptography know that there is a system of keys that if you encrypt something with private key, you can decrypt it with public key. If you encrypt with the public key, you can decrypt with private key. Right? They are dual. And that's how we sign the documents. We sign it with private key, but anybody can verify the signature in a second with my public key, which everybody knows. Right? So it will generate a public key for you. It will generate a private key for you. The public key is hashed to a small number, which is your address, they call it. And that's your name. That's all. Your name is not whatever it is. So now I can give you some money, or you can give it to somebody else. And it's very difficult to trace where it is coming from, although it is easy to trace in the sense that somewhere the Bitcoin is going to come from $1. Wherever there is a boundary to the physical world, you have to give your name. So when you give somebody $1 and say, give me 1 Bitcoin, they will ask you, what is your name, what is your credit card number, where you live. And that is the point you lose. Right? But after that boundary, the Bitcoin travels totally anonymously. And so this wallet program will do for all that for you. So you don't have to be a cryptographer to use it. So let's say Bob says, I bought this 1 BTC to Alice. So first he puts a pointer to the previous BTC. So he says that I got this BTC in one transaction whose hash is this value. So it is not a real number or anything like that. This pointer, all the pointers in this world are basically the hashes. So when I say I point to that transaction, so we have to find that transaction and hash it and see, yeah, this matches this. Then yeah, that is the transaction I was pointing to. And this is my public key. And this is the address of Alice. This is who I want to give. Now address is the hash of the public key, right? So this is public key of the recipient. Now whole thing is hashed, and then that hash is signed with the private key. So now this is recorded that nobody else can do this thing because your signature is there. So it can be proven that you gave 1 BTC. And now we have to make sure that you did have that BTC, so we will have to check the previous hash and all that, right? And now when Alice wants to spend that 1 BTC, she will have to do the same thing. She will have to point to this transaction saying that this is where I got that 1 BTC. And so there is a ledger, a book which is kept where in the banks they keep it and in our home we keep it, where we write down that I gave $1 to Alice, or Bob gave $1 to Alice. And then in my case, I write down that I put $2 for the grocery and I put $3 I got electronics return. That is a ledger, right? Everybody has it. The main thing here is that this ledger is replicated all over the world, and there is only one ledger. So all the transactions of the world are replicated in this ledger, and this ledger is replicated at millions of nodes. Now you would think that is impossible. Right? How can you take all the transactions of the world and replicate them all over the world? It was impossible 5 years ago, but today, if you put all the transactions in one place, in Bitcoin at least, it is 9 gigabytes. And I have 9 gigabyte, multiple times of that in my iPhone. Right? You have terabytes. I have actually terabyte in my pocket over there, 4 terabytes, small disk. So storage is no problem. Right? So the whole world transaction can be replicated infinite times and it still be no problem. All right? So this ledger which is actually kept right now in a bank and therefore it can be hacked, now it is kept in multiple copies all over the world and so it cannot be hacked. Now these transactions are linked, so this is a transaction chain. However, it is too much to deal with the transactions individually. So what we do is we put them in a block. So we take maybe hundreds of transactions and put them into a block. And then we take another 100 and put them into a block. So the blockchain, we found a blockchain rather than a transaction chain. Because now the blocks are easy to handle because basically there are lots of transactions, first of all, and they are all verified. So everybody who had seen those transactions before has verified that the signature is valid, that this guy has a private key, and so on and so forth. So these are all valid transactions, and they are just chained. And the chain is single, as I said, only points to the backwards. And again, all the pointers are simply the hash. So basically, the hash of this block, n minus 1, is the value which is in this block. Okay? Now the blockchains make the miners ensure that all transactions in the block are valid. So the miners, who are the miners? The miners are the people, and you can be a miner. There is no, you don't have to go to somewhere and fill out a form that I want to be a miner. You can just become a miner tomorrow. You have a computer, you can say, I want to be a miner. You take all the transactions that are coming to you, verify them, put that into a block, and say, here is the block. Okay? So the miners are people that we don't know. They're all over the world. And the thing is that the miner who is the fastest, who has the most computing power, wins. Okay? And it is not always the same person who wins because this thing that they have to solve is random. And even if I have the same computer as you have, sometimes you will win, sometimes I will win. So the probability of one person winning all the time is very low. And the miner is rewarded, and that's how everybody mines, is that the person who wins first and whose transaction is the first, who comes out first with the block, he gets few bitcoins, and that is why we call it mint. So that is how the bitcoins are generated, is that people who are mining, they get rewarded by allowing them to print new money a little bit, not too much. And there is a limit for that as well. You cannot just print $1 billion bill. You can just, there is an amount as to how much you can mint today, and how much, so the amount, basically depends upon the time. Everybody knows how much is that amount. When you send it to some place, your block, they will all check it out that you didn't lie anywhere, that you solved the puzzle correctly, that you put the correct amount, that every transaction is valid, and so on and so forth. So your results are checked by lots of miners and lots of nodes. The chain at some point looks like this. It doesn't look like a single chain because this block was generated by somebody and they were pointing to the same block as this person was pointing to, and similarly this was pointing to that block. So towards the end, the chain may not be single. Basically it becomes a fork kind of thing. But what will happen is only the blocks that have the highest difficulty will win, and so if this block had solved the puzzle which was highest, will win and these two will lose, and so eventually this is the chain which will survive. Okay? And if you have survived 6 blocks in the chain, so 1, 2, 3, 4, 5, everybody who is in this block, they can spend the money. If you are not in the 6th block, then you have to wait a little bit because we are not sure. Right? Each block takes exactly 10 minutes. So 6 block is 1 hour. So if you get the money, you can spend it after an hour. And you can spend it right away, but basically it cannot be verified and your transaction will be delayed. But anyway, so the idea is that as the transactions which are older and older, they are very well verified and very well done, and they are stored everywhere, and you are in solid grounds. The transactions which are here, there is some confusion and question about them. And all this timing, all these numbers were all done by this one guy, Satoshi Nakamoto. He thought about everything, 10 minutes, this, that, and so on. Now here is a trick he came up with, that each transaction does not really have that I want to give to Alice. It could be that I want to give to Alice, but he said no, I want to give to this thing which could be a program. So you write a program, I want to give to this program. So you execute that program and whatever the result comes out gets that money. So there is a script, there is a program that is written for the output. And similarly, when you spend the money, you have to give a program that really compares and matches with that output script. So you give an input script that verifies, yeah, that I am. So basically, it could be very simple script. It says, I want to give it to Alice, basically a number, and then the Alice supplies the private key, and somehow, you can, and she won't give you a private key, but she would give you a proof that she has the private key to that address, and she can use the money. So that is the simplest script, but it doesn't have to be that simple. So you can pay to a public address hash, and there are more complicated scripts. For example, one script could be multi-signature. So there are 5 people in the bank, in the company. 2 of them, if they sign it, then the script is valid. So if you provide 2 signatures, you get the money. And this is very common in the banking business. One signature will not do. You could pay, we already talked about pay to script hash. However, when Nakamoto designed this thing, he put a restriction. He says that these programs cannot be Turing complete. What is Turing complete? Every program that we generally, for simple reason, I'm just going to simplify here, is Turing complete because you can go back and forth, you can have jumps, and you can have while and do loops. But he said, no, we cannot have do loops, we cannot have any loops, we cannot have any jumps, so it has to just execute straight because all these miners have to execute it. We don't want them to get into a loop forever. So he excluded loops. So this is Turing incomplete. So everything cannot be represented with this program. So somebody came up with the idea that why don't we allow people to write Turing complete programs? Okay? And when that idea came, then suddenly the blockchain became very, very interesting. Because now you can write any contract, and every contract can be written as a program, and you can write any contract, and it might take longer because of this while this and that. So here it is. I want to give to Alice $100 if IBM stock goes below 5. I just want to bet $100 to Alice. Okay? So someday Alice provides a proof that the stock today is $5, less than $5, she gets the money. This kind of script can be written very easily. And unlocking script is simple. Property exchanges can happen. If the building is complete, then they get the payment, whatever they were due. If the building is not complete, the payment doesn't go to them. You would like that, right? If the building is 80% complete, they get 80% payment, 20% is still held up. So these kinds of contracts you can write. And so now we have something called smart contracts. Contracts that the machines can handle by themselves. You don't have to go to the court, you don't have to go to anybody. All the miners, everybody knows that the money is not theirs because the script has not been provided. Okay? And so now we have smart contracts, smart properties, smart everything. Now the smartness definition has changed. A few years ago I told you smartness was networking. Now the smartness of that you are working on the blockchains. And that means the financial, so who can use this thing? Of course, there is a whole financial industry which is going to use it, which includes currency, private equities, public equities, bonds, derivatives, commodities, mortgage, crowdfunding, microfinance, microcharity. Anywhere it's very simple. Then you just change the Bitcoin to that thing and it works. But public records, land titles, you know how much you go to, I know this here, I have gone to this through process, this one, where you want to change your property from your father's name to your name, you go and pay them some money and the guy will change it. The money goes into the guy's pocket, right? And that is not possible with this system. Now with this system, basically the condition would be there and you have to provide the proof and all that. So this is why all the things which are centralized today, land titles, vehicle registries, business licenses, criminal records, passports, birth certificates, death certificates, these can use blockchains. Private records, contracts, signatures, wills, trusts, escrows, other semi-public records, physical asset keys, intangibles, patents, copyrights. You don't have to go to the patent office to reserve a patent. you can put the patent. You can just put the patent in the public, basically everybody knows that you patented it. Networking applications. Of course, this is, now I'm coming to my end, by the way. So networking, this is a conference on networking, and I'm a networking guy, so what can we do? Well, there is something called Namecoin, and that is actually a domain name registry. So we have this DNS, which is centralized. If you want to get the name raj.in, you have to go to some registry and pay them, and they register it, and they charge you every year for that. Well, with this system, you don't have to pay every year. You just register, and the only thing right now is that DNS, as it is, does not resolve those names. So you have to have some extensions to DNS to resolve the names which you have registered on Namecoin, which is based upon blockchains. And right now, they're only registering .bit names. So second thing I have to do tomorrow is go and register Jain.bit before anybody else takes it. And same thing for you. Right? And its own currency to pay for the registration. Now, DARPA has issued an RFP for secure decentralized messaging using blockchains. So DARPA is already now getting into this, how networking can be done with blockchains. There is the IPFS, which is the decentralized secure file serving. Basically what it is that if you want to get the files from somewhere, now the files are all over the world, multiple copies, this IPFS will get you the right copy. Secure means it is guaranteed that this is the correct copy. It has not been changed. StoreJ is a decentralized cloud storage. So your stuff will be not stored on iCloud or Google Cloud or anything. It is stored on the world cloud, totally decentralized. And one name is a digital identity, which basically you can do using wallets. And obviously you can see IoT has a lot of application of this. Now when you have billions of devices and the devices are providing information, somebody will pay for that information, and how do you pay them a microcent? This is the way. So ISPs, internet service providers, obviously they are very much going to this. They can do mobile money, billing, digital assets, roaming, connectivity. Wherever money is involved, obviously ISPs can do that, but in addition to that, they can do a lot of other things. And so ISP Verizon Venture has invested into a company called Filament, which is doing industrial assets. Orange Digital Venture has invested in Chain, which is a company which is working on financial services. Do, which is a Dubai telecom, has pilot program for secure transmission of electronic health records. So right now the health records basically again are using centralized system. They want to decentralize that. That brings me to the end of my talk. And we still have 3 minutes left, maybe. I'm counting it right here. So the 5 points are, current trend is to make everything decentralized. Everything decentralized. Everything that is centralized today will be decentralized. And I don't know whether this will happen or not, but that's the current hype. Bitcoin is a decentralized currency, and blockchains are used for global consensus Bitcoin transactions. And the blockchain, so this was 1.0 they call it. Now they call it blockchain 2.0, which is the not money, but anything else, which is contracts and other applications. And this is an opportunity for startups, venture capitalists, and researchers. Okay, any questions? Yeah.
So is there any mechanism which constrains decollaborations from making more Bitcoin? It said that more power, more Bitcoins can make.
Oh, power, yeah. Okay. So I can restate the question. I know what it is. Is that the way the consensus comes in Bitcoin, at least, is that you have to have a compute power. And these miners now are actually big powerhouses, whole data centers. So the question is there another alternative, or is it that you really need to buy a data center to a miner? So for Bitcoin, that is given. But for some of these alternatives that they are talking about, this is another research topic. Can we get away from this unnecessary waste of time doing this hashing? And so, for example, one alternative says that, okay, we will compute the prime numbers. Okay, at least it will be good for the world if we have computed the prime number. We increase the knowledge. And some people did that if they have some, genome, something, and they are doing that with people who are going to do blockchains. use your computer to solve this puzzle. So those are the other alternatives. And then there are other alternatives which say that no computing. It's basically based upon something else. So it's a research topic.
So is it the case that big companies have already implemented Bitcoins?
Yeah, is it the case there?
So is it the case that big companies who have access to computation power have already mined Bitcoins?
Yeah, this is given. If 51% of the power is with the bad guys, they win. Right? Hopefully 51% is with the good guys. Okay, so that's the thing. Okay. Any other question? Yeah, boliye. Yeah, microphone le jaओ. Oh.
So quick question.
Yeah.
Which is, on one of your early slides, you used the term hack proof.
Hack proof, yeah.
And as I've done a lot of work in cybersecurity.
Yeah.
The red flag goes straight up. And so we know, for example, you mentioned Ethereum. It was hacked a couple of months back. Okay, $79 million. People could literally
Mount Gox.
system. This is the DAO.
Huh?
Organization.
DAO, yeah.
And prior to that, Mount Gox, which you just mentioned.
Yeah.
Also, so one of the sort of issues in vulnerability is that people prove the vulnerability, even if Nakamoto did not prove the vulnerability of this protocol, security of this protocol,
yeah.
other people have looked at that. But the problem is that all these protocols have to be embedded in the hardware and other software in the ecosystem surrounding it, which often are vulnerable and allow the processing.
Yeah, could be.
So what are your thoughts on this? Because I agree, this looks a lot more secure than anything out there. So I'm fully...
No, so the thing is, okay, let me summarize what you said, and I agree with that. Basically, we have said that, maybe this system is secure, but we have to put software around it which can kill it, right? And that is true. So everything, we will have hardware and software around it which can make it insecure. And so this is basically a research topic again as to what can we put around and how much security is, as to what layer, because this is an onion, and if this core is secure, doesn't mean that everything else is secure. So yeah, that can happen. You had a question there, yeah.
It's a very dangerous question. I just wanted the effect on black economy, effect on taxation system of different countries.
Right.
And effect on guarantee land.
Right. So Indians will love it. Black money is easy. Because government has no control. You don't have to register with the registrar how much money you paid and how much property you got, right? So the black money is clearly Bitcoin is Bitcoin. So basically, previously people used to put money in Switzerland. Now you don't put it in Switzerland. You put it in Bitcoin. And so yes, because of this, the central authorities will lose their control. And because of this, any centralized country like China, Russia, they have banned it. USA has not banned it because, USA is not that centralized, right, as authority-wise. So most of the authoritarian countries have already banned it because their authority goes away on the very first thing, right? And that is where they need it most. So the Chinese and the Russians are the ones who need this kind of stuff more because they are so much controlled from the outside. But yes, there are bad applications of this as well. Taxation is same thing. Yeah, so the thing is, what will happen is, right now, we are saying that nobody can figure it out, but everybody can figure it out. The other part of this is that governments can figure out as to who, basically everything is public, right? And in some sense, everybody knows about everything, except that we cannot really associate easily the address with the name. So when I put one Bitcoin, I put a number and that number I just randomly generated. So to associate that number to me is still difficult, right? But other than that, government could make a rule that you have to pay taxation. So when you go to Dell and buy a computer, you pay taxes, even if you pay in Bitcoin, right? So yeah, taxation will be there, and if the legal tender is done. With illegal tender, you don't get the taxation today, and you will not get it tomorrow. Okay, yeah.
Supposing this Bitcoin is,
Huh?
supposing the Bitcoin economy takes off, then if you have everybody transacting with Bitcoin, what happens to the size of the ledger?
What happens to the real currencies? Somehow the echo, I can't hear it. Can you say it again? Takes off, yeah. What happens to, and after that I didn't hear. What happens to?
Size of the ledgers.
Size of the ledger, yeah. Right, so this is the thing. As I said, I first didn't believe myself that everybody could store the whole world's transaction. But right now the size of the ledger is 9 gigabyte. Right? It could become 9 terabyte maybe, okay? 9 gigabyte and 9 terabyte are very far apart, right? And the storage is increasing. See, what is happening is storage and computing power are both increasing exponentially. In fact, I think storage is probably increasing faster. I'm not sure, but increasing. So right now, nobody is worrying about that part, right? But there is another solution though. Not everybody has to store, something that happened 10 years ago. So there are nodes that have petabytes of information, and they will keep all the things, and somebody can ask them, can you please tell me this transaction? And not one node, there are many nodes which have a lot more information, and you can just keep the head of the queue. So most people like me will keep only the head of the queue, and we can ask other nodes about the previous older transactions. Does that answer your question? So we don't have to keep everything. Yeah, right. I mean, scalability issue. Now, a scalability issue right now has not happened, and these guys are, basically, as I said, there is a whole group of people. So basically now Bitcoin is a public, just like IETF, there is a group that works on these protocols. It's an open meeting. They have a meeting and they have modifications and they have, RFCs, they call BIP. And so these things are being solved as they happen. Yeah.
So in Bitcoin, the problem is that there is a lot of computing required. So suppose you take an application like share market, how will this compare with the latency? It will obviously take a lot of time to compute rather than just process those. So in the long run, do you see share market?
No, actually, Nakamoto had thought about that problem too. So I think the question was that the computation power, may become more or less or something, and then it may take a long time to settle these transactions. So he made a formula. The transactions will take only 10 minutes to settle, because the problem that you are given to solve should take exactly 10 minutes. If the computing power becomes twice as fast and you can solve it in 5 minutes, then after 2 weeks, the complexity will be changed back so that it will take 10 minutes. So this is adopted every 2 weeks. So it will take 10 minutes today, it will take 10 minutes tomorrow, it will take 10 minutes in 2020.
How does it take care of sequencing? Like two people are wanting to buy the same share, but one person gave the order before, but his order was processed later.
No. The order will not process later. So what will happen is, suppose both of you put the order, you have already put some kind of time stamp and everything else, your transaction has gone through, and it's the miners who do the validation. So somewhere it has to be validated. It's just the validation which is delayed, but your transaction is valid. So my transaction, if I made it at 7:01 and you made it at 7:02, mine is still at 7:01, even though they were settled at different times. So there is a time for transaction and there is a time for settlement. It's like this: today when you buy a stock, it is settled after 3 days. You buy a house, it is settled after 3 days, right? So it doesn't matter really, but for those 3 days right now, I cannot sell the house. Actually, in my case, I could not even get another mortgage, because they said if you take another mortgage, there is blah blah blah. So for 3 days there is a settlement period. Okay, all right. Thank you very much. I really appreciate it.
Very good.
Thank you. Okay.
Very interesting talk.
Thank you.
Appreciate you putting up with us. I know that about Mana and schedule, but very fascinating. We can come all the way to enlighten this industry topics and very beginning of we have one more topic now.
Who's next?
Thank you so much.
You take this. No. Oh, sorry. You want to use the computer? Okay, go ahead. Yeah, that's okay.
No, I have the computer.
Oh, actually, I forgot to show one slide, which I should show now. So these slides are all available. If you can scan this thing, you can download them now. Or if you just remember that bit.ly address, you can get them there, or you can just go to rajjain.com and you will get it. Okay. What else? Okay. Thank you. So what are we doing with this computer? Taking it out? Okay.
Increasingly, the percentage of talking we are non-physically is increasing, right? So that is internet conversation essentially part of the day, and it's a matter of time. Most important technology to organize, get schedule, and have a block very well, so that we can actually have access to them, see them, and probably purchase them. So how is this possible? Can we make it more interactive? Can we make it more effective, more efficient? So this is the thought process of Professor Harish Tani. Can we make it a natural language way of cataloging internet products in the internet commerce era? Professor Harish Tani is from IIT Kanpur, and his specialty is into the language processing itself, including links with about 50 interesting areas. So let's hear what Professor Tani has to give his thoughts on about natural language processing or making sure how internet commerce can be possibly become more efficient. We had the first topic of process and talking about how the internet-based possible security can be taken care. Fascinatingly, and ensuring that how is it bots, is it human interaction. Then Professor Rajan talked about how for the internet transaction, common transactions can be made possibly more more virtual by including blockchain concept to the requirement. Now we have Professor Harish talking about how the cataloging can be made more natural language based. Better person.
When is your talk?
It's supposed to be 3:45.
So, here is the problem. I have a talk at 3 o'clock at Bell. I'm just leaving right after this. But I will get your slides someday somehow. See what you're working on right now.
We just launched a new division that is financial.
Huh?
We've just launched a new division that is financial.
You're working on this thing?
No, I'm not sure. It's
Yeah, I can imagine that.
Good afternoon. I have one simple doubt.
Yeah.
How the first transaction was happened in Bitcoin?
Oh, the guy Nakamoto did it.
Yeah, how he did? How he
He just put the first block which says that I'm minting it with no transactions, and he got 25 bitcoins for that. So he just started the first block is a small block.
Okay, he himself is created.
He himself created, he got the money, and then he started giving to people.
Okay. I didn't understand first
Yeah,
transaction.
no, that's a good question. That's a good question. Actually, you could have asked, or you should have asked.
No, there is a lot of echo. The reason I didn't answer.
Yeah, I couldn't understand the question. That's why. Yeah.
I want to know about more about Bitcoin.
Oh, actually, so I forgot to put some slides. So if you got my slides, there are references at the end.
Okay.
Yeah, there are references in the presentation. I just didn't flip them. I should have flipped them.
We can download that slides, no, sir?
Huh?
We can download that.
Yeah, you can download it right now. You just go to rajjain.com and talks. No, you can just go to talks. No, just Google it. I'll tell you what. You just go to rajjain.com. You will see talks, papers. Go to talks. And then this is the last talk I've given. So this is on the top.
Thank you, sir.
Okay.
My research topic is chains only.
Huh?
I am doing research on chains only.
Oh, is that right?
Yeah. And almost suitable to this implementation part.
Uh-huh.
So can I have your card, sir?
Sure. You don't need my card, I tell you, because you just Google it, you get my home address, my phone number, my everything. So, it's very public.
Recently I have developed on chain theory also. Let me find out whether it's suitable or not.
Okay. Yeah.
So then I'll come.
Sure. Yeah.
Taxonomy of books and
Sure.
also had a taxonomy for non-books. What they wanted was when vendors put up things on their site, they would like to get them tagged. When vendors put up something, then typically they will have a already title very often, and almost always they will have a short description. There is a book or there is a notebook. And the plan then was to take this information and construct it.
Yeah, I know.
And label this information, that is label the product. Using a static taxonomy. Taxonomy is not necessarily static.
I actually studied your MTech about computer system performance analysis. Okay, so it's really nice to see you here. Actually, some concept I had from your concept right now I'm doing PhD, sir. So those things I have the regression analysis, the leveling and factor analysis. Those things I have, sir. I'm really nice to see. I just
Good. I appreciate it. Yeah. See you. Thank you. Yeah.
And there is a principle path label because existing reference ontology is a large tree which has labels. So if you have something like, let's say shoes, so you start from
Hardware and software around it, which can make it insecure. And so this is basically a research topic again as to what can we put around and how much security is, as to what layer, because this is an onion, and if this core is secure, doesn't mean that everything else is secure. So yeah, that can happen. You had a question there, yeah.
It's a very Jain question. I just wanted the effect on black economy, effect on taxation system of different countries.
Right.
And effect on guarantee land.
Right. I mean, so Indians will love it. Black money is easy. I mean, because government has no control. You don't have to register with the registrar how much money you paid and how much property you got, right? So the black money is clearly Bitcoin is Bitcoin. So basically, previously people used to put money in Switzerland. Now you don't put it in Switzerland. You put it in Bitcoin. And so yes, because of this, the central authorities will lose their control. And because of this, any centralized country like China, Russia, they have banned it. USA has not banned it because, USA is not that centralized, right, as authority-wise. So most of the authoritarian countries have already banned it because their authority goes away on the very first thing, right? And that is where they need it most. So the Chinese and the Russians are the ones who need this kind of stuff more because they are so much controlled from the outside. But yes, there are bad applications of this as well. Taxation is same thing. Yeah, so the thing is, what will happen is, right now, we are saying that nobody can figure it out, but everybody can figure it out. The other part of this is that governments can figure out as to who, I mean, like basically everything is public, right? And in some sense, everybody can know, everybody knows about everything, except that we cannot really associate easily the address with the name. So when I put one Bitcoin, I put a number and that number I just randomly generated. So to associate that number to me is still difficult, right? But other than that, government could make a rule that you have to pay taxation. So when you go to Dell and buy a computer, you pay taxes, even if you pay in Bitcoin, right? So yeah, taxation will be there, and if the legal tender is done. With illegal tender, you don't get the taxation today, and you will not get it tomorrow. Okay, yeah.
Supposing this Bitcoin takes off.
Huh?
Supposing the Bitcoin economy takes off, then if you have everybody transacting with Bitcoin, what happens to the size of the ledger?
What happens to the real currencies? Somehow the echo, I can't hear it now. Can you say it again?
Supposing the Bitcoin economy
Takes off, yeah.
what happens to the size of the ledger? Supposing we start
What happens to, and after that I didn't hear, what happens to?
Size of the ledgers.
Size of the ledger, yeah. Right, so this is the thing. As I said, I first didn't believe myself that everybody could store the whole world's transaction. But right now the size of the ledger is 9 gigabyte, right? It could become 9 terabyte maybe, okay? 9 gigabyte and 9 terabyte are, very far apart, right? And the storage is increasing. See, what is happening is storage and computing power are both increasing exponentially. In fact, I think storage is probably increasing faster. I'm not sure, but increasing. So right now nobody is worrying about that part, right? Now there is another solution though. Not everybody has to store, something that happened 10 years ago. So there are nodes that have petabytes of information, and they will keep all the things, and somebody can ask them, can you please tell me this transaction? And not one node, there are many nodes which have a lot more information, and you can just keep the head of the queue. So most people like me will keep only the head of the queue, and we can ask other nodes about the previous older transactions. Does that answer your question? So we don't have to keep everything.
Yeah, but the race, it's not that if you don't have the transaction, the race is going to win or the...
Yeah, right. I mean, scalability issue. Now, a scalability issue right now has not happened, and these guys are basically, as I said, there is a whole group of people. So basically now Bitcoin is a public, just like IETF, there is a group that works on these protocols. It's an open meeting. They have a meeting and they have modifications and they have, RFCs, they call BIP. And so these things are being solved as they happen. Yeah.
So in Bitcoin, the problem is that there is a lot of computing required. So suppose you take an application like share market, how will this compare with the latency? It will obviously take a lot of time to compute rather than just process those. So in the long run, do you see share market?
No, actually, Nakamoto had thought about that problem too. So I think the question was that the computation power, may become more or less or something, and then it may take a long time to settle these transactions. So he made a formula. The transactions will take only 10 minutes to settle, because the problem that you are given to solve should take exactly 10 minutes. If the computing power becomes twice as fast and you can solve it in 5 minutes, then after 2 weeks, the complexity will be changed back so that it will take 10 minutes. So this is adopted every 2 weeks. So it will take 10 minutes today, it will take 10 minutes tomorrow, it will take 10 minutes in 2020.
How does it take care of sequencing?
Huh?
Like two people are wanting to buy the same share, but one person gave the order before, but in order of later.
No. The order will not process later. So what will happen is, suppose both of you put the order, you have already put some kind of time stamp and everything else, your transaction has gone through, and it's the miners who do the validation. So somewhere it has to be validated. It's just the validation which is delayed, but your transaction is valid. So my transaction, if I made it at 7:01,